So we're going to talk about a better way of dealing with these nested if-then-elses that we've seen that are making our functions a little bit hard to read. And it turns out that there's a better mechanism in OCaml for writing these sorts of functions, and it's called pattern matching. And this is a way of inspecting a value of a given type and looking at the different possible cases in an easier to read and in fact a more powerful way that leads to shorter and more understandable code. So let's look at a very simple example. Our previous factorial function was let rec fac a equals, well, if a equals 1, then the answer is just 1, otherwise the answer is the factorial of a minus 1 times a. Now, we can rewrite this using pattern matching in the following way. Let's write let rec fac a equals, and then a new construct we haven't seen before. We use the word match. We say what we want to match. Well, we want to look at a, and then we say with. So match a with, and then we're going to list what we call the cases. Well, the first case is 1. So this is the same as a equals 1. And we put arrow. Well, in that case, the answer is just 1, same as above. So that's our first case. And then we put another case. We use a bar here, which looks a little bit like the 1, but in fact it's a bar. And so what we want to say now is, well, in any other case, and there's a special pattern for that, which is the underscore, that just matches anything. So in any other case, we want fac a minus 1 times a. So these two functions are exactly the same in their operation, but the second uses pattern matching and the first uses the old if then else. This being quite a simple example, it's not very easy to understand why this second one is simpler than this first one. The first one seems pretty simple. For a better example, we're going to introduce a new type. We've only seen integers and bools so far, but for the next example we need a new type. There's another type of thing used for representing letters and building up words and so on in OCaml, and this is called a char, which is short for character. So, and you write it using the single quotation marks. So a, in quotation marks, is a thing of type char representing a character. And in the same way, question mark is also a thing of type char. So let's write a function to work out if a character is a vowel. Well, we could write, this doesn't need to be a recursive function, we could write is vowel x, that's the name x, not the character x, equals, well, match x with, well, we can say a is a vowel, so return true, or e, or I, or O, or U, or anything else is not a vowel, false. So this is a function is vowel, and it has type, well, it's a function, so there's an arrow in the middle, and then it takes a char and it gives us back a bool, true if it's a vowel, false if it's not. Now you can imagine that if we wanted to write this using lots of nested if-then-elses, if x equals the character a, if x equals the character e, if x equals the character I, and so on, we would either end up with a lot of nested ones, or we would have to use the double bar, the function for logical OR. So this is a little bit simpler. It's much easier to read than that. But in fact, we can even do better than that, because notice that these true, 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 well, they're all the same. We don't want to repeat ourselves. So in fact, we can write out, we can combine those cases and say let is val x equals match x with, and then we can just write A or B or pattern C. Sorry, forgot myself there. It's not A, B, C. It's A, E, I, O, and U. Well, those all want to result in true, and anything else wants to result in false. And that function has the same type, works in the same way, and is easier to understand. So pattern matching is a way of avoiding nested if-then-elses, and a way of giving us a way to deconstruct a value and look at all its possibilities and decide what to do with each. It's another tool in our box. We've only written very small programs now, but when you come to write larger programs, you'll use a lot of pattern matching and rather less nesting of if-then-else constructs, simply because it's easier to read. It has a number of other advantages, which we'll discuss too. These patterns are matched against in order, so the order of the patterns is significant. OCaml will check if the first pattern is correct and do that and return this. Then it will, if that's not correct, it'll check the next one. If that's not correct, it'll check the next one right to the end. And if we miss out a case, OCaml will detect there's a case missing. So if I missed out this final case here, a warning will be generated that says, well, do you know what will happen if the character B is given to this function, for example?